All right. Hello, everyone. Hope everybody's doing well out there. I'm Thomas, and welcome to my channel. I do educational videos on obscure esoteric matters. And fairly recently, we got done with the unit on the Tree of Life, or at least done for now. We're going to revisit that, and we're going to be revisiting it throughout because it's kind of the fundamental basis of the other stuff that we're going to study here. So now we're into the reciprocal system of theory, which is a theory of everything, a system of theory of everything that was originated by Dewey B. Larson back in the middle part of the 20th century and has been carried forward by Dr. Bruce Perret, Dr. KVK Nehru, and also Dr. Gopi Krishna and others in the 21st century. Today, we're going to resume the reading of Dewey Larson's speech that he gave in 1986 in front of the society that was formed to kind of propagate the reciprocal system of theory, which was the ISIS, Institute for the Society of a Unified Science. And so you might not be able to understand any of this unless you go back to the beginning. This is like the fifth installment, or maybe even the sixth installment of the reading of this. So you would need to go back to the first one, and really you should probably go back to the first video on the reciprocal system. I believe this is number 13. Okay, we're going to start with number 47 with, I guess, point 47 or entry 47, where scalar motion in space is three-dimensional, the speed in one of the dimensions may be greater than unity. But, as indicated in number 29, the effective magnitude of a combination of motions is determined by the net total of the scalar speeds. And because there are two low-speed dimensions, the net speed is less than unity. In this case, then, the motion in the high-speed dimension acts as a motion in equivalent space and modifies the magnitude of the change of position in space, rather than causing a change of position in time. Okay, just one of the key terms here is the equivalent space. We met this, I think, yesterday also, but the equivalent space, basically, Perret explains equivalent space, okay, we go back to the beginning of Larson. The universe is made out of motion. Motion is the relationship between space and time. Space and time are the same, but they are reciprocals of each other, but they have the same characteristics. But from our vantage point in this universe, we are in the material sector. There's another sector called the cosmic sector. That may be where our soul is. But we, as physical beings, are in the material sector, and so are our instruments that we use to measure things. We are in the material sector, and from the material sector, we are incapable of seeing time. We can't see time. We only can see space. So when something occurs in time, we do not see it in time. We see it in equivalent space. And since space and time are reciprocals, we basically see the opposite thing happen in space. Now, one idea of that is like the white dwarf star. So in Larson's, figuring of it, the white dwarf star is a star that explodes beyond the speed of light. Now, remember, the speed of light is like the bound. Like for Einstein, the speed of light is the maximum speed of the universe. For Larson, the speed of light is the midpoint of the universe, or really even the neutral point between two universes, the reciprocal and the cosmic universe, or the material and the cosmic universe. So when a stellar explosion, a nova, where a stellar explosion blows out in space, but once that explosion gets beyond unity, beyond the speed of light, then that explosion is an explosion in time instead of space. So it blows up in time, but we don't see time. So what we see is what we see in equivalent space. So instead of seeing the explosion in time, what we see is actually an implosion in space. The things move all further together in space. So that's what a white dwarf star is. It's a compact, super dense star as a result of an explosion in space, in time, instead of space, because it is beyond the speed of light. Okay, that I just wanted to kind of clarify that with, hopefully clarify that. Okay, number 48. We identify the material atoms with scalar rotation in equivalent space as the atoms of the electronegative elements. Okay, so the electronegative elements, I believe those are the ones that are on the right side of the periodic table. Yeah. Okay, then number 49, we also encounter motion in equivalent space within the units of space. Here, no modification of the normal progression of space can take place because of the discrete unit postulate, but motion can take place in time. Inasmuch as this motion within the spatial unit does not alter the position of time of the unit as a whole, changes within the unit that result from the motion are observed in equivalent space rather than in actual time. Number 50, the existence of a spatial unit where motion has properties quite different from those prevailing in the region outside the unit explains the discontinuity in physical properties at very short distances that has led to the development of quantum theory. Okay, the existence of a spatial unit where motion has properties quite different from those in the prevailing region outside the unit. So he's making a delineation here between motion outside of a unit of space and that inside the unit of space. Now you have to go back to Larson's discrete unit postulate. Everything, basically the quantum, everything is based on discrete units. There's no, 0.6 or 0.3 or something like that. It's all integers. And you have to have at least one integer, at least one, to have something. And so there is a realm, just like the speed of light is a unit speed, that is one. The speed of light is one in this. And if you're going faster than the speed of light, it could be 2 or 3, and it can be adjusted. But then, it could be half or a third. You use unit fractions. But also, in addition to that unit of speed, you also have a unit of time and you have a unit of space. Okay, so this unit, it turns out, according to his calculations, that this unit of space is, I think it's approximately equal to 4.56 times 10 to the minus 8 centimeters. So that's the unit of space. And anything that's inside of that unit of space, that goes beyond this boundary, and that he calls here the existence of a spatial unit where motion has properties quite different from those prevailing in the region outside the unit. Okay, so if you're outside that unit, you're in the material sector, but you're also in what he calls the time-space region. But it might actually be more reasonable to call it the space-time region, but he calls it the time-space region. But if you're within that unit, any type of motion within one unit of space, everything within one unit of space is in time. Okay, so he has this thing that's called the time region. So the time region is the region inside one unit of space. Now he has the same thing on the other side for what he calls the space region. The space region is everything that is inside of one unit of time. And his unit of time is extremely small. It's like, I think it's like 6.58 times 10 to the minus 16 seconds. So in every second there are, that's how it works. It's 1.52 times 10 to the minus 16 seconds. So in every second there are 6,000 trillion units of time. But anything inside that unit is in space. So he's constructing. There's really 4 regions there, and they're divided by the speed of light, unit speed. And on one side you have the material sector, and on the other side you have the cosmic sector. But within the material sector, there is like the normal region, which he calls the time-space region. But then there is also the time region. So the time region is within unit space. And on the other side, the cosmic sector, he has the space-time region, which is the main region. But then inside of one unit of time is the space region. So there are 4 different sectors there. You can see this in the, I don't know how to pronounce it, but the Tajitu, or the yin-yang symbol, where you have the, you have the circle, and on one side it's white, and on the other side it's black, but within the black side there's a little white circle, and within the white side there's a little black circle. That's the same kind of structure that he's talking about here. So he says the existence of a spatial unit where motion has properties quite different from those prevailing in the region outside the unit explains the discontinuity in physical properties at very short distances that has led to quantum theory, the development of quantum theory. So they had to come up with quantum theory to explain, what the fact that there's a difference between these 2 different regions, between the time-space region and the time region in particular. Okay, number 51. The progression of the natural reference system relative to the spatial system of reference is always outward, but as indicated in paragraph 10, the natural datum level or physical zero is at unity rather than at the mathematical zero. Within a unit of space, outward from unity is toward zero. It follows that the progression within the unit, as seen in the spatial reference system, is inward. Okay, number 52. From paragraph 31, the gravitational motion is inward. This direction, too, is inward relative to the natural datum, unity. Within a unit of space, it is therefore outward in the spatial reference system. So this is another key point. In the time-space region, gravitation is inward. Everything moves toward each other. But within the time region, in that small little region there, where everything is in time, gravitation is inward in time, and so therefore it is outward in space. So gravitation basically moves everything toward that boundary, toward that unit boundary. If it's outside in the time-space region, it moves things closer together toward that boundary. But if it's inside the time region, it actually moves things farther apart toward that boundary. And that creates a lot of effects that you may not foresee. Okay, number 53, no stable equilibrium between the atoms or aggregates of matter is possible at separations greater than 1 unit of space. The inward and outward motions are equal at the gravitational limit, but this equilibrium is unstable, as the change in separation due to any unbalance between the opposing motions increases the unbalance. Within a unit of space, where the directions of the basic motions as seen in the spatial reference system are reversed, the effect of a change in separation between atoms due to an unbalance of the opposing motions reduces the unbalance and eventually results in the establishment of a stable equilibrium. Okay, we're just going to do number 54 here. The positional equilibrium in equivalent space that is established within a unit of space accounts for the existence of the crystalline state of matter. I think he could have just called it the solid state of matter. Bruce Perret's footnote is called the crystal is continuous in the time of the reference system, but discontinuous in the space of the reference system. I would say more that the phenomenon that he's talking about is called solid cohesion. Within a unit of space, there's an equilibrium that develops, and that leads to, I guess it is called solid cohesion, where within a unit of space, there's an equilibrium because everything is moving toward that boundary, that unit of space boundary. And so that leads for him to solid cohesion and also the interatomic distance. And that's why there's a kind of a set distance between atoms of the same kind that are structured in a lattice, or that are aggregated together. They naturally go to a certain distance apart from each other, and this is based on um, being in the time region. And um, you know the basically you have like a tug of war between gravitation and the progression. In the outside region, in the time space region, the progression is moving everything apart from each other, and gravitation is moving everything toward each other. At a certain point, um, you get so far away that the gravitation is attenuated, and so things will move away from each other. Within that distance, gravitation overpowers the progression and things move toward each other. But within the unit of time, it's different, because the progression is actually moving everything toward each other, toward this kind of 0 point. And gravitation is moving everything toward the one. So gravitation is always moving toward one, and the progression is either moving toward 0 or toward infinity. Okay, now we just you may be totally lost. You probably want to go back to the start, but this is all kind of to show how difficult this stuff is, and how huge of a task this was for Larson to not only formulate this, but to put it into language. And he didn't always do it right, so that's an important thing. Okay, we'll see you tomorrow. Have a great day.